check this out. This will be a lab and a little demo for how the starter works. First thing you'll recognize, here's your starter, right? Basic standard starter. You can pretty much see what we got. Got a couple connections and a small connection. Let's focus those in. This one's a slightly different style, but all these starters are going to work the same. This bottom part's the solenoid, and then this top part is the actual motor. So if we were to look at this one, which was the same as that first one, what I'd like to show you here is this is the big battery cable. So this literally comes right from your battery, and it goes to this terminal right here. So that terminal, if we were to look at it, let's call that terminal B, where it says 12 volts, right? So that one's always going to come directly from the battery. That means your starter has voltage all the time. Key on, key off, doesn't matter. It has voltage. And then the other thing to consider is the starter is grounded, the case is grounded to the block, right? So that's your big positive there. And then your big negative, if you will, the ground is the case. Cool? Okay, now from there, we have a couple more terminals. This we're going to call the S terminal. Now this may be different from one manufacturer to the next, but if I disconnect this, you can see there's a small terminal in there, right? That is what comes from, let's say, the ignition switch, or in a more modern vehicle, that might be PCM or BCM controlled, control module controlled, right? So if we get 12 volts here, and we've got ground here, which we always do, if we give 12 volts to the small S terminal, that's going to connect big battery to this terminal down here, which we'll call the M terminal, because it jumps over here and goes to the motor. So what that looks like on this one, right? If we do 12 volts here all the time, cool, and then we give it the voltage on the S terminal, which is missing because it's a cutaway, that will make it so your big positive will be connected to your motor, to your M terminal, and that'll send the voltage actually in to spin the motor, okay? And that's the part that I think people get a little confused on, right? So if I want to do down and dirty diagnosis, I could pop this cap off, make sure it's getting voltage from the battery, and it is. Then I would turn the key, and that key will give 12 volts to the small terminal, and when it does, this solenoid should transfer 12 volts to the M terminal, which will go down here and make the motor spin, okay? That's really the test. So if you're in the car testing it, boom, make sure it's got it here, make sure it gets it here when you turn the key. And really, if, let's say you don't have any voltage here at the S terminal, you need to backtrack, right? All the way back to the ignition switch or to the starter relay, etc. Cool. But if you have 12 volts here, which you most likely do, and you do get 12 volts here that correlate with the key, you're pretty much, it's the starter, right? You're going to replace the starter. However, to make you an educated technician, to help you understand a little bit more, I want to demo it a bit further. We got to talk about some parts. So here, we'll talk about the solenoid, right? So this whole entire assembly is the solenoid. When we actually do give that 12 volts to the small, to the S terminal, to the solenoid terminal, it's actually going to close these contacts. And so there's two things that happen. This moving is going to shoot our pinion out, and I'm going to grab a screwdriver and show you. But additionally, there's actual contacts here, and that's how the B plus terminal is going to contact the M terminal, right? So like what I showed you over here, you got the B plus, and that B plus is going to be connected to the M. Or like on this one, you got the B plus and it's going to connect to the M. It connects inside on the contact plate. And that only happens when the solenoid gets thrown in, right? Then it'll make contact. So let's say that we give 12 volts to the S. It's actually going to throw this over, right? Because this is the pull-in coil. And so when that is activated through electromagnetism, it's going to draw this over, right? That's really that's the purpose of this solenoid. Boom. And there's going to be an electrical contact made right there. That's going to pass it into the M terminal, which will go into the actual motor. Then when it goes into the motor, obviously this is going to spin, right? But there's one more part. Because this pull-in coil through, look what happens. Okay, it's a little, there you go. So it's a little tough for me to do with one hand, but when I pull this in far enough, you'll see it'll actually throw that starter drive gear, they may call the Bendix, into the flywheel, into the ring gear, the flywheel or the flex plate ring gear. Cool? All right, so let's just say that those contacts were bad. What you would get is you get 12 volts here, you get 12 volts from the key, and you might get like a somewhat of a sound, like you might hear this click. It might throw the starter gear out, but it won't make contact and it won't run the motor. Technically, that's a bad solenoid, right? Because the contacts are part of the solenoid. Modern day technicians were replacing the starter, but it's kind of made us dumb, right? So I want to take you to the next level. Cool. So if the solenoid clicks, boom, but you get no voltage on the M terminal, it's because the contacts are bad. Cool. All right. But wait, there's more. Let's say that we get the 12 volts on the solenoid small wire and the solenoid throws and it does make contact, and you can verify that by measuring voltage on the motor terminal. M is motor, right? But it still doesn't turn. We could have some other issues. So for example, without making this a crazy video about how the motor works, we've got to have 12 volts and ground going into the back of this motor to activate the electromagnetism that makes the motor turn, right? And so one of these motor segments is going to get 12 volts and ground, and that's going to drive it. But then once it gets to a certain point, we actually don't need 12 volts and ground. We need to flip it, ground and 12 volts, and that'll draw the next segment in. And so we're rapidly switching 12 volts and ground. And that's basically where this M terminal comes in. It goes to the back of this motor, and that little piece down there that you can see spinning, that's the commutator, and that's going to provide the switching 12 volts ground, ground 12 volts, 12 volts ground, ground 12 volts. But the way that we make contact with that are through these brushes, pole shoes. So right in here, there are brushes, a little hard to see, riding on that right there. That's riding on that commutator. If we had an issue with one of those brushes, we wouldn't get contact, right? So you'd get 12 volts here, but it wouldn't go here and provide the 12 volt in ground switching. So actually, we'd have to go through and figure out what's going on with, maybe the brushes are worn. And that's probably one of the more major failures. We'd pop this apart and we can replace the brushes. And it's also possible that you could have an open in the commutator segments as well, in which case you'd have to replace the commutator, which is really the whole armature and the commutator all one piece, right? So ultimately, again, it just needs a starter. But so you know a little bit more about what's happening in here. Those brushes wear down, they're carbon. When they wear down, it'll eventually get to the point where the brush is kind of thin. The spring trying to push it down doesn't really push it down that well. And then the car doesn't start. And so you come over here, Primitive Pete style. Try it now, Tony. And boom, it starts. You may very well have broken loose the brush that was kind of sticking because it's worn down and the spring's not providing a ton of tension, right? So if you break the brush free and it works, cool, that's a motor. So if you're a real mechanic and you go to start the car and you hear the click like the solenoid throws, you might come over here and bang on this and it might start. Then you'd be like, yeah, it's a bad starter, but I want you to be more specific. It's probably a brush sticking in the back of the starter at the commutator. Sometimes what can also happen is if you had an open in this commutator segment, you might be at the open right now, and if you bang on it and this moves just a little bit, it might get the magnetic field within range to pull it over. It's a lot harder to get it moving than it is to keep it moving. So if you have one bad segment, there's going to be like a probability that it'll work a bunch of times, and then once in a while it won't work. And if you bang on it and it moves just a little bit, it'll work a bunch more times until, of course, it lands on the dead one, and then it won't work, right? Either way, for the modern day technician, this is all needs a starter, but you should know a little bit more. Now, let's say we wanted to bench test it, right? Because we talked about in the car, you're measuring that this voltage is good. You're going to measure that this gets voltage when you turn the key, whether it's push button, that's computer controlled, whether BCM or PCM or whatever, but make sure it gets voltage here. If it's got voltage here and it gets voltage here and it doesn't work, it's bad. Cool. But bench testing is a different thing. So look, I've got this jumper. It's really just a battery running up to the positive cable. Cool. So that's now going to the battery. Then I've got this grounded at the case. Cool. So if I turn this on, it doesn't do anything. And the reason it doesn't is because remember, we need to give voltage to this, the little solenoid terminal, which will then electromagnet pull over, make the contacts, jump it to the M terminal and zing, okay? So what I've done to do that, I've taken this, just a basic push button starter switch. I've connected one end of it to positive. I could have done it down there, but I did it here. So that's going from positive to the switch. It's momentary, so right now there's no voltage leaving. If I press the button, voltage will go to the S terminal. All right, so let's test that. Oh, must have turned it the wrong way. I think I did have it on. Here we go. All right, there we go. Two things happen. One, I give voltage to the S terminal. That pull-in coil kicks over, it'll make the contact, and a lot of times the solenoid will kick this out directly, or other times it depends on the drive. Sometimes these come out not due to the solenoid, but regardless, this is at a minimum making electrical contact, which is sending voltage to the motor terminal, which is going to start this spinning. And sometimes the way they work these, that'll push the gear out by itself, right? So there's our operation. Now, a couple little notes. One thing is, this needs to lock in the counterclockwise direction, but it needs to freewheel in the clockwise. Okay, that's a potential failure point. If it freewheels both ways, the car will sound like this when you go to start it. But it's almost like it won't catch. That could be because this one-way clutch is failing. So I just checked that, and I just checked it with my hand. I mean, I'm not making a lot of force, but I at least checked it. Another thing is these teeth could be stripped or worn or broken, and same, the ring gear, flex plate or flywheel teeth could be stripped or broken or etc. Right? So just getting a visual there. But additionally, we got a couple other things that we should check. So commonly with like diagnosis, let's say that we have excessive resistance on this positive cable. That would give us an excessive voltage drop. So if we wanted to voltage drop this, I'd go ahead, I'd put my red lead probably down here at the positive. I'd put my black lead right here, right? And so that would voltage drop test it. We should drop little to no volts across this positive cable, and then it'd actually crank it. And then the reading on the meter would tell me how much voltage is dropping across the cable. All right, so standing there like that with those meter leads, red on the positive battery and black on that actual, probably right at the B plus terminal, boom, and then cranking, check your voltage drop. It should be fairly low. If you got under a half a volt, I suspect you're pretty good. If you start to get like a full volt of drop, you're gonna have a problem in this big positive cable, right? You could check the ground side as well. You would do the negative on the negative terminal, and you could actually put your positive right here, right? Because your negative is going to go to the most negative part, which is down there. You put your positive here, and you should drop very little. I mean, really 0.2 volts is going to be a little more typical. Cool. So that would tell you if you have a good ground to the case, but you're not just going to do it just like this. You're going to do it and then crank the engine over. That's going to put this under a lot of load, a lot of demand, right? So there's your starter voltage drop test, both on the positive and the negative. But we could test a little bit more. If we had positive voltage drop, or any type of voltage drop, that's going to lower our amps, right? So through Ohm's law, if you have a voltage drop, you have excessive resistance. If you have excessive resistance, that's going to make less amps, right? The more resistance, the lower the amps, okay? So if I wanted to do some additional testing, what I may do is go ahead and do like a draw test, all right? So like right here, I could zero this out. All right, so as I'm adjusting that, get it right where I want it. And then I did do something interesting. I've got to actually look at this clamp. I need to flip it. The way I know is look at that arrow, right? So the current flow is going in this direction. It's leaving the battery, conventional theory at least. Cool. Now when I go to do this, and I should tell you, this clamp is 1 millivolt per amp. Okay, so you can't check amperage in line with this. It's going to be 80 amps or something, 100 and something amps. All right, so let's call that at about 120. So what I just measured, there's 120 amps going through here. Again, I've got it set to millivolts, and here on this meter, on this inductive clamp, it is 1 millivolt per amp, right? So if we've got 120 millivolts reading on the meter, that means 120 amps on this inductive clamp. I could do some basic diagnosis. Now this is free, right? This is not bolted up, this is unloaded. There may be a spec for this. Let's just say the spec was 120, then it'd be a pass. If it was in the car, if it's a 4-cylinder, you know, this number I'm about to tell you may vary, but they will have a spec a lot of times for just the bench version of the starter test. But if it's in the car turning the engine, you're typically going to get, I don't know, maybe about 150 amps for a 4-cylinder, maybe about 200 for a V6, maybe about 250 for a V8, right there about, right? So if I go to troubleshoot something like that, and this is a concept on the ASE, but if I have lower amps, low amps, so it's, let's say it's a, we'll make it a V6, 200 amps. All right, V6 with 200 amps. If I have 100 amps, that's low flow. That's probably electrical resistance. That could be resistance in the terminal, resistance in the cable. That could be resistance at the B+. That could be resistance in the starter contacts. Seen that one before. That could be resistance in the M terminal, right? Resistance makes low amps. What if it's high amps? Well, that could be, let's say, that could be that this starter bushing or bearing is bad and it's very hard for the starter to turn. If the starter has a hard time turning, the amps spike up. So if this bushing is bad or whatever, or let's just say maybe the engine is starting to seize. The engine has excessive drag on the crankshaft because it's got, you know, a spun rod bearing or something. Or what about the engine turns and it's turning the belt and the alternator has seized, right? High amps mean there's mechanical difficulty turning something, whether it's the starter parts or whether, remember, it could be the engine or even engine belt driven accessories will make your starter draw test high amps, right? So low amps is going to be electrical resistance. High amps is going to be mechanical resistance. All right, so there's a few more things we could do. Like we could do the voltage drop. I think you can visualize the voltage drop. That's hard to do with me holding the phone. So hopefully this helps you understand starters a little bit more.